What if the biggest breakthroughs in human progress were not born from comfort, but from discomfort, from the refusal to accept limits that everyone else quietly agrees to live with? Because the moment you question the sky above you, you begin to realize that even the sky is not the limit. For decades, satellite internet crawled along at the pace of old promises, slow, delayed, and frustrating, especially for people living beyond cities, as if geography itself had decided who deserved connection and who did not. Most accepted this as reality. But progress never begins with acceptance. It begins with dissatisfaction. And dissatisfaction is where vision takes root. When Starlink emerged, it wasn't just a new service. It was a challenge to an entire mindset that had settled into complacency. The question was simple but dangerous. Why must satellites sit so far away that speed becomes a luxury and latency a curse? That question echoes a deeper truth about life itself. Because every system that stops evolving does not remain stable. It quietly falls behind. The story of Starlink choosing low Earth orbit over traditional satellite paths is not just a technical decision. It is a lesson about proximity, urgency, and the courage to move closer to the problem instead of orbiting safely at a distance. Traditional satellite companies chose geostationary orbit because it was familiar and predictable. A single satellite hovering far above the planet, covering wide areas but paying the price with long signal travel times. Signals had to travel tens of thousands of miles up and back down, introducing delay that users felt in every click, every pause, every frozen screen. Medium Earth orbit tried to balance coverage and performance, but still remained a compromise built on old assumptions. Starlink rejected compromise by moving closer, placing thousands of satellites in low Earth orbit, where distance shrinks, latency drops, and the internet begins to feel immediate again. This decision mirrors a philosophical shift that resonates beyond technology, because progress accelerates when you reduce the distance between intention and action. When something is closer, feedback is faster, mistakes are revealed sooner, and improvement becomes continuous. In life, just like in orbit, distance creates delay, and delay dulls momentum. Many people admire innovation, but fear the risk required to achieve it, forgetting that safety often hides inefficiency. Starlink's design shows that complexity is not always the enemy. Sometimes it is the price of excellence. Coordinating thousands of fast-moving satellites is far harder than managing a few distant ones. But difficulty is not a signal to stop. It is a signal that the goal matters. Elon Musk believed that if humanity was serious about a connected future, the infrastructure had to be reimagined from first principles, not patched with incremental fixes. Low Earth orbit was not chosen because it was easy, but because it was honest about the problem. Latency was the enemy, and altitude was the cause. By lowering altitude, Starlink shortened the journey data had to travel, turning delay into responsiveness and frustration into usability. This shift disrupted legacy satellite internet because it exposed how long the industry had been settling for good enough. When users experienced faster speeds and smoother connections, expectations changed overnight. And once expectations change, there is no going back. This is how disruption truly works, not by loudly attacking competitors, but by quietly raising the standard until old models collapse under their own limitations. The deeper message hidden in Starlink's orbit choice is about proximity to purpose. When you stay too far from the people you serve, you stop feeling their pain. When you move closer, discomfort increases, but so does clarity. Low Earth orbit brought satellites closer to Earth, and that closeness translated into empathy for users who needed real-time connectivity for work, education, and survival. It reminds us that innovation is not about distance or grandeur, but about relevance. Every meaningful change begins when someone dares to move closer than everyone else is willing to go, knowing that the closer you get, the more responsibility you carry. As the idea of moving satellites closer to Earth began to take shape, a quiet tension formed between possibility and risk, because every bold decision carries a moment where failure feels more likely than success. And this is where most visions die. Low Earth orbit promised speed and responsiveness, but it also introduced a new set of challenges that could not be ignored or wished away. Satellites in LEO move incredibly fast, circling the planet in minutes rather than hours, which means they cannot simply stay fixed over one location. To provide continuous coverage, Starlink had to deploy not dozens, but thousands of satellites, all working together as a single, coordinated system. This was not just an engineering challenge, it was a test of belief. Could software manage what hardware alone could not? Could a dynamic, ever-shifting network outperform the static certainty of traditional orbits? Many critics doubted it, pointing to the complexity, the cost, and the unprecedented scale, and for a moment, the doubt felt heavy enough to slow everything down. Suspense lives in these moments, when the future is undecided and the present feels fragile. Because innovation always walks a thin line between brilliance and collapse. Every launch carried not just satellites, but expectations, and every failure risked proving the skeptics right. Yet the deeper truth was that staying safe in geostationary orbit had already failed millions of people who needed better internet, but were told to accept delay as unavoidable. Starlink's gamble was that technology had finally reached a point where proximity could outweigh stability, where speed could triumph over simplicity. Medium Earth orbit, often seen as a compromise, could not deliver the dramatic latency reductions that real-time applications demanded, and compromise rarely leads to transformation. Latency is more than a technical metric, it is a psychological experience. When a video call pauses, when a page hesitates to load, the human brain feels friction, and friction erodes trust. Starlink understood that trust in the internet is built on immediacy, on the illusion that distance does not exist, and low Earth orbit made that illusion believable again. As satellites move closer, signals move faster, and suddenly online experiences felt natural rather than mechanical. This is where the suspense sharpened, because success would not just improve performance, it would redefine what users expected from satellite internet entirely. If Starlink succeeded, the old industry would be forced to change or fade. If it failed, it would become a cautionary tale about ambition exceeding reality. In the middle of this uncertainty, the system began to work. Data hopped from satellite to satellite with astonishing speed. Ground stations synchronized seamlessly, and latency dropped from hundreds of milliseconds to numbers that rivaled terrestrial networks. What once felt impossible started to feel inevitable. And inevitability is the most unsettling force for legacy systems, because it exposes how fragile their dominance truly is. Elon Musk often speaks about bending reality through persistence, not by denying physics, but by understanding it deeply enough to work with it rather than around it. Low Earth orbit aligned with physics instead of fighting it, accepting that distance equals delay, and choosing to reduce distance rather than mask delay. This mindset reflects a broader philosophy that progress accelerates when we stop treating limitations as rules and start treating them as variables. Still, the suspense did not disappear, it simply evolved. With thousands of satellites came concerns about space debris, orbital congestion, and long-term sustainability. These were not small issues, and ignoring them would have undermined the very future Starlink aimed to build. Addressing them required constant iteration, rapid deorbiting plans, and an acceptance that improvement is never finished. This is another lesson hidden within the orbit choice, that innovation is not a single leap, but a continuous series of adjustments guided by feedback. User experience became the ultimate judge, not press releases or promises. When people in remote areas could finally attend online classes, run businesses, or connect with doctors without frustrating delays, the value of low Earth orbit stopped being theoretical. It became human. And yet, just when it seemed the path was clear, new questions emerged about scalability, affordability, and global regulation. Could this system truly reach everyone, or would it stall under its own ambition? Suspense thrives on unanswered questions, and at this stage, the answers were still forming. But what had already changed was irreversible. Expectations had shifted. Once people experienced low-latency satellite internet, the old excuses no longer sounded reasonable. The industry could no longer hide behind physics when physics itself had been reimagined through design. In that realization, the real disruption took hold. Because disruption is not about technology alone. It is about changing what people believe is possible. In the final stretch of this story, clarity begins to replace uncertainty, not because the challenges disappeared, but because the purpose became impossible to ignore. And when purpose is clear, momentum follows naturally. Starlink's choice of low Earth orbit ultimately proved that innovation is not about chasing novelty, but about solving real problems at their root. By placing satellites closer to Earth, Starlink reduced latency, increased speed, and reshaped the user experience in ways that legacy systems never could. Not because they lacked intelligence, but because they lacked urgency. Urgency is the quiet engine behind every meaningful transformation, and it grows stronger when you accept that improvement demands discomfort. Low Earth orbit is uncomfortable, demanding constant coordination, rapid launches, and continuous monitoring. Yet that very discomfort creates adaptability. In contrast, geostationary orbit offered comfort through distance, but distance softened accountability. When something breaks far away, response slows. But when it breaks close to you, action becomes immediate. This principle extends beyond satellites and into personal growth, where proximity to your goals forces honesty and accelerates learning. Starlink's architecture reflects a belief that systems should evolve at the speed of feedback, not tradition. As more satellites filled the sky, coverage expanded, speed stabilized, and the internet reached places once left behind by cables and towers. Farmers, students, emergency responders, and entrepreneurs began to experience connectivity, not as a luxury, but as a tool. And that shift altered lives in ways metrics alone could never capture. The disruption was no longer theoretical. It was visible in daily routines, in businesses launched, and in opportunities unlocked. Elon Musk often emphasizes thinking from first principles, stripping problems down to their fundamentals, and Starlink's orbit decision stands as a practical demonstration of that philosophy in action. Instead of asking how satellite internet had always been done, the question became how it should be done if starting from scratch. The answer led closer to Earth, closer to users, and closer to reality. Medium Earth orbit faded into the background as an incomplete solution, while geostationary orbit revealed its limitations under modern expectations. As the system matured, skepticism slowly transformed into curiosity, and curiosity into reluctant admiration, because results have a way of silencing doubt. Yet the deeper message of this journey lies not in technical diagrams, but in mindset. Progress favors those willing to rethink foundations rather than decorate old structures. Starlink did not win by adding features. It won by redefining the battlefield. In doing so, it reminded the world that disruption is not an act of rebellion, but an act of service to the future. As global demand for connectivity continues to rise, the importance of low-latency communication will only grow, and systems that cannot adapt will feel increasingly outdated. The success of low Earth orbit satellites signals a broader transition toward responsiveness, resilience, and speed, values that resonate across industries and disciplines. This story invites reflection on where distance still creates unnecessary delay in our own ambitions, and where moving closer might unlock progress. It challenges the assumption that stability is always safer than change, revealing instead that adaptability is the true form of security. The legacy satellite industry learned that history does not guarantee relevance, and the world learned that bold ideas can rewrite rules once thought permanent. As Starlink continues to evolve, it stands as proof that the future belongs to those who design for what people need next, not what worked before. In the end, the choice of low Earth orbit was not just a technical preference, but a statement of intent, a declaration that connection should be fast, accessible, and human. It shows that when vision meets execution, even the vastness of space can be reshaped to serve life on Earth, and that realization leaves us with a simple but powerful question about our own paths forward. If you are benefiting from our topics, please subscribe, like, and turn on the bell notification so you can see our new videos early.